All right, let's look at prime factorization. Before we look at that, we're going to see what a prime number is. A prime number is a number that's only divisible by 1 in itself. So it only has two factors, we could say. Some examples of that are 7, 11, and 17. You notice with 17 here, for instance, the only numbers I can multiply that are whole numbers to get to 17 are 1 and 17. That's it. There's no other numbers we can multiply, and that's why we call it a prime number. Conversely, a composite number has more than two factors. So some examples of that are 10, right, because we can do 1 times 10. We could also do 5 times 2. 325 is another example. You know from your divisibility rules that 5 will go in there since the last digit is a 5. And you also know 1 times 325 are factors. So there's more than two factors there. 14, same thing. 1 times 14, 2 times 7. So there's 4 factors with 14. It's a composite number. Now, when we have prime factorization, or as we like to say in math sometimes, factor trees, all we're doing is we're breaking up a number like 24 into a bunch of smaller factors that are all prime numbers. And we're going to get a product out of that. So the number 24, if we were to break that up, we could say 12 times 2 is 24. And 2 is a prime number, so I'm just going to circle that. That way I know I'm done with that. And 12 can be broken up a little bit further. We could do maybe 4 times 3. Now we could have done other ways to get here, and we'll explain that in a second. Now I know 3 is a prime number, so I'd circle that. 4 is still not a prime number though, because 1, 4, and 2 are factors. So I'm going to break this down even more. So it'll be 2 times 2. So ultimately we're left with that for a factor and that for a factor. So if I was to write this out at the bottom here, we'd have 24. And it would really be 2 times 2 times this 2 right here, a third 2. I'm just trying to put all the numbers in order. And then times the 1, 3 we have. And another way of writing this, if you remember from exponents, we could put 2 to the third power times 3. It's just the shortened version of it. So same number here. If you went a different way, I just want to show you to get the same answer. So if you did, instead of 12 times 2, you said, I know 6 times 4 is 24. You could even say 8 times 3. We'll do 6 times 4. I know I can break down 6 into 2 times 3. 4 would be 2 times 2. And these are all prime numbers. And when we go down to the bottom here, I know again I have 1, 2, 3 2s, so 2 times 2 times 2 times that 3 there. Now I would just write 2 to the third power times 3. This one's a little bit more difficult because it's a bigger number, but just use the divisibility rules. So I know last digit here is a 5, so I know 5 is going to be one of the numbers. And actually 5 is a prime number, so I can circle it right away. And what times 5 is 425? I don't have any idea. So I'm going to do the division out here. Unfortunately, we have to take that step. I know we don't like to do work, but hey, that's what we're here to do, right? 425, how many times does 5 go in? So 8 goes into 42 5 times. We get 8 times 5 is 40. We're going to subtract here. And we get 2. We'll bring down that 5, and that's 25. 5 goes into 25 5 times, so we get 85. Now, since 85 is not a prime number, I'm not going to circle it, just so I know. If we break down 85 a little bit further, I know again it ends in 5, so I can bring another 5 down. And if you don't know what 85 divided by 5 is, you can again do it out. I know that it's 17, and I know, like we talked about at the beginning, that 17 is going to be a prime number. So I'm going to write my circle around that 17. So when I list 425 out, I know there's going to be two 5s there. So I'm going to put 5 to the second power times 17.